It's me, Miss B, and in this video we're looking at the Unit 5, Lesson 4, practice problems for Illustrative Math Algebra 1. So let's dive in here. We're actually going to skip one problem, so you'll see that the numbering isn't quite right. We're not going to do question 7, so when we get there, you'll see that it goes just straight from 6 to 8. That's why we decided to cut out question 7. So starting here. A new bicycle sells for $300 and it is on sale for 1/4 off of the regular price. We want to select all expressions that represent the sale price of the bicycle in dollars. Okay, now with a sale price, if we're taking 1/4 of the price off, that means what we're going to pay is the other 3/4. So the sale price of the bicycle is what we actually have to pay. So this is a little bit different here. So 1/4 off is the discount, but they're not asking what the discount is. They want the sale price of the bicycle. This is what we pay after discount. So we have to describe what's left. With that being said, this first expression here would actually just tell me what the discount is. So it's not going to be enough to actually like tell me what the sale price of the bicycle is. B, however, 300 times the 3/4 does tell me what I would pay after the discount is taken out. So that is the base idea. Let's keep looking at our other options. Option C here says 300 times 1 minus 1/4. So we can think of 1 and 1/4 as parts of the original price. So this is saying, hey, take the entire original price and then subtract 1/4 of it. And then multiplying by what that price is gives us that actual dollar amount. So C also works. D is not going to work because that's literally just subtracting the number 1/4 from 300, and that doesn't quite work. But E, on the other hand, is going to work because of PEMDAS. There's actually parentheses in here, if you imagine it that way, because we would do multiplication first instead of the subtraction. So what we're actually doing is taking the 1/4 of that 300 and then subtracting it from our original 300, right? So using PEMDAS, we would, or order of operations, we're going to choose E as well. So B, C, and E are all solutions here. Let's look at question 2. So we have a computer that costs $800 and it loses 1/4 of its value every year after it's purchased. Because, technology gets old, and so newer things come out, better things come out, advances are made in how fast we can make computers go, so it's going to lose value. It's not going to be worth as much money. We're going to complete this table on the right to show the value of the computer at the listed times. So when it is year 0, or time in years is 0, that's the original price, that's our initial value. So this is still going to be $800. That's what we're going to pay right away for it. So after 1 year, it's going to lose 1/4 of its value. That's the same as multiplying it by 3/4, just like in the question above, how we had 1/4 off of the price. Or you can divide it by 4 and then subtract that from the original amount. So 800, if we cut that into 4 pieces, is $200, which means it's going to lose $200 this time around for its value. So what's left is actually going to be 600. Then the next year, it's not just going to lose $200 because it's no longer worth 800. So we're going to actually then multiply our 600 by 3/4 or 3/4, or if you prefer decimals, that would be 0.75. And I highly suggest you do that on a calculator. Make sure that you're accurate, but this is going to be $450. After 3 years, definitely going to need a calculator for this one. We're going to take that 450 and multiply it by 3/4, and that is going to give us something with cents. So it's going to be $337.50. So part B says write an equation representing the value t years after it's purchased. Well, this very last section here is going to show what the expression is I would use in order to actually help me write that equation. So what I've been doing is taking that $800 and then each year multiplying it by the same number, but that is 3/4. And since that is repeated, this gets the exponent on it. So it's kind of the opposite of something doubling, but we use the same format. The only difference is I'm not putting 1/4 in here because it's losing that amount. I'm taking that away from 1, meaning I have to use my expression to show what's left. So my equation for part 2 is going to be V equals 800 times 3/4 to the power of t. Now part C says, use your equation to find v when t is 5, and what does this value of v mean? So we're going to say v equals 800 times 3/4 to the power of 5, and this definitely plug into a calculator. This is going to come out to around 180. I'm going to round it to the nearest cent. So 189.84. So what does this mean? Because this is a price or a V for a value of a computer or how much it's worth. So this means that after, now we plugged in 5, so 5 was t, that's our year. So after 5 years, the computer is worth about $189.84. And that is all for question 2. So let's keep going. Question 3, back here, I'll zoom in. We have a piece of paper, and it's going to be folded into thirds multiple times. Now it gives us that the area A of that piece of paper in square inches, after n number of times being folded, is A equals 90 times 1/3 to the power of n. So they want us to actually use this to solve. So they're saying, what is the value of A when n equals 0? Well, that means n is my exponent right here. So they're saying, hey, raise that to the power of 0. Well, lucky for me, I know, let's use my thinner marker here, A, if it's 90 times 1/3 to the power of 0, I know anything to the power of 0 is 1. So this is the same thing as saying A is 90 times 1. So that would mean that the value of A is 90. Now, what does it mean in context? That means the area of the piece of paper before we fold it. So the area of the paper before it gets folded is 90, and then what did they say? Square inches? Square inches. That's what it means. Okay, so part B is asking us how many folds are needed before the area is less than 1 square inch. This is where a calculator is really, really handy. We're basically going to be taking 90 and dividing it by 3 over and over and over. It's the same thing as multiplying by 1/3 over and over and over. So definitely use a calculator to help you with that and plug in different values of n. So from there, I would just keep going up until I got to an answer. So I would start with 1, and then 2, and then 3. And what you'll find is that we actually needed to fold it 5 times. So use calculator. You're going to do 90 times 1 over 3, and to the power of t. You're going to keep going, and you would need that the times that we fold it would be 5 before we actually reach less than 1 as our answer. Okay. For part C, they're saying the area of another piece of paper in square inches after n number, oh, I'm sorry, it's not T. That's right, that was the previous question. It's n number of folds. The previous question was T with the years on the computer. The area of another piece of paper in square inches after n folds is given by b equals 100 times 1 over 2n. What do the numbers 100 and 1/2 mean in this situation? Well, we knew at the 90 in the original question, that was the area of the paper before it was folded. So we can say 100 is, I'm just going to say the original area of the paper. And they told us that this piece of paper is folded into thirds, and that is where you see this piece come up here, the 1 over 3. The 1/2 is going to tell us that this paper is being folded in half. 1/2 means the paper is folded in half at multiple times. Okay. If we keep going to question 4, we have this one. So at the beginning of April, a colony of ants has a population of 5,000. The colony decreases by 1/5 during April. So we want to write an expression for the ant population at the end of April. Well, it's decreasing by 1/5. So if I just multiplied by 1/5, that would be how many ants they lost. So if they're starting with 5,000, I want to multiply instead by how many ants are left, not 3. This is 4/5. So 4/5 of the ant colony will be left. So during May, the colony decreases again by 1/5 of its side. So if we're multiplying by 4/5, which is what's left over, this is going to be the 5,000, but now we're multiplying by 4 over 5 a second time, so we're going to square it. If this colony continues to decrease by 1/5 of its size each month, we want to write an expression for the ant population after 6 months. Well, guess what? If we're multiplying by that number each month, because that's what's left over, we're going to have 4 over 5 to the power of 6. So after 6 months, this would be the expression. Now, they didn't ask us to evaluate it or give the answers, so you only have to write an expression. You don't actually have to plug it in a calculator to figure out how many ants. Okay, question 5. Lynn has 13 mystery novels, and each month she gets 2 more. So we want to select all expressions that represent the total number of mystery novels after 2 months. So if she has 13, she's starting with 13, but she's getting 2 more. So that to me sounds like adding 2. If she was doubling her number of books, that would be multiplying by 2. So in this case, we want to represent it after 3 months. Oops, sorry. There was a hair on my screen, and when I swiped, that's how I changed my page. So let's go back to this question here. Okay, 13, and then she's adding 2 books for 3 months in a row. So A, with that repeated addition, would be accurate. Now, B is not going to be accurate because that would be if she was doubling her books each month. So not B. C is also not going to be correct because that would be the same as B. 2 times 2 times 2 is 8. So we're not going to multiply 13 with 8. But D is correct because that would be 2 plus 2 plus 2. 6 is the same as 2 plus 2 plus 2. So D also works because it's going to give us the same amount as A. And E is correct also because if you did 13 plus 6, you would get 19 as your answer. And we have one last page. We're going to do questions 6, 8, and 9. Again, we're skipping question 7. So for question 6, we have an odometer. It's the part of the car that shows the number of miles that you've traveled since the car was produced, like in its lifetime. So before a road trip, the car's odometer reads 15,000 miles. And during the trip, the car travels 65 miles per hour. So we're going to complete this table. Before this road trip, it was 15,000 miles. So that's our initial value, or our amount right here. And if we drive 1 hour, that's 65 miles per hour. So we're going to drive 65 miles. So 15,065. If I drive for 2 hours, I'm going to drive another 65 miles. So I'm just going to add. So this would be 15,130. If we drove 3 hours, we would have 15,195. If we drove for 4 hours, it would be 15,260. And then if we drove for 5 hours, it would be 15,325. Okay, so that was part A. They just wanted us to complete the table. Part B says, what do you notice about the differences of the odometer readings each hour? So that's saying, what do you notice about the difference here? Difference means subtract. So if we subtracted these two, we would get that they're different by 65. And the same actually works here and all the way down because we were adding 65 each time. These are each going to be different by 65. So we can say the difference each hour is 65. That's what we notice, just that it is that much no matter what hour we're looking at. With the one previous, it's always going to be 65. So part C, if the odometer reads n miles at a particular hour, what will it read 1 hour later? Well, if n is my miles, 1 hour later means I'm going to add 65 miles for that 65 miles I would travel in that hour. So n plus 65. Question 8 says a function multiplies its input by 3/4 and then adds 7 to get its output. We just want to use function notation to represent this. So I would say, in this case, because they don't give us things to use in order to define it, I'm going to use f of x. F is our default function name, and x is our default variable when we don't have anything for our input. So it multiplies its input by 3/4. So we're going to take x, multiply it by 3/4, and then add 7. And that is our answer. And the last question is evaluating pieces of a function. So it gives us a function 2x minus 5, or f of x equals 2x minus 5. They want to know what is f of 0. That means when we input 0, what do we get? Well, if you input 0, 0 times 2 is 0 minus 5, so you just get negative 5. F of 1/2 is going to be 1/2 times 2, which is 1, minus 5, so that would be negative 4. If we put in 100, this would be f of 100, so we would have 200 minus 5, which is 195. So here, actually, I'm going to put boxes around each of the values that are my answers, since I'm kind of showing my work horizontally here. And then the last one is, what is the x value when f of x equals 9? So in order to do this, we are going to say 9 equals 2x minus 5, and I'm going to solve this by doing my work downwards here. So we would add 5 to both sides. That means this is 14 equals 2x, and we can divide both sides then here by 2, and we would get that x is equal to 7, and that is the answer for this one. And that is everything for this assignment. So thank you for joining me, I guess, and this has been Unit 5, Lesson 4 of Illustrative Math, Algebra 1.